Hi, I'm Chris Williams. I'm the CMO at Arima Data, and we're going to be talking about what is synthetic data. At Arima, we talk about two really important things in marketing. One is marketing mix modeling, the other one's synthetic data. Let's just jump right into that. Synthetic data has three different key takeaways. One is it's national data at the individual level. Privacy law does not apply to the synthetic individuals, and it's ideal for sharing between marketers, agencies, publishers, broadcasters, and any other media vendor or data processor. One quick and easy way to think of it is it's like a game of SimCity. It's a model, there's rules applied, there's a map applied, and there's individuals, the Sims. But it's much more scientific than that. Obviously, we have different ways of using data and applying experiments. One is in vitro, in vivo, in situ, and in silico. And obviously, in silico is the computer model, and it's been around since about 1987. That's using synthetic data and modeling to try and determine what is the experiment, what are the outcomes of the experiment, just using computers. There's two Canadian leaders in the area of synthetic data. One is Replica Analytics up in Ottawa, and they're in the medical field. The other is Arima, which is in the business and marketing area. And what you can see here is on the right is the academic white paper that Winston wrote around the generation of synthetic data. If you're interested in getting that, it's publicly available. It's peer-reviewed, published, and just let me know, and I can send you a copy. The privacy aspect is one of the most important pieces of synthetic data. Ann Cavoukian, who's the former privacy commissioner of Ontario, says this in an article at IAP, is that because there's no real identifier that is applied to the synthetic data, there's no one-to-one correspondence between the synthetic individual and the real individual. It's the future of privacy and data utility. And what do we mean by data utility is the ability to share that data amongst many stakeholders in the business field. So sure, you in a first-party data situation, you can have a lot of granularity with your data. But in order to be able to share it, you have to de-identify it. And that means you're on that curve where you're removing data, especially if it's medical data or sensitive data about children or any sensitive data. That data has to be removed. And so you're into a place where the data gets de-identified and generalized down to the point where you feel comfortable actually sharing that data. Whereas synthetic data, you start off with the granularity you need, and basically you can share it and use it in the ways that you want. Khalid up at Replica has written a book on synthetic data as a whole process, and he's gone into the privacy area to ask about international privacy regulation like GDPR and CCPA. And here again, the concept is understood and supported in the sense that it says synthetic data is not real data about an individual or about a person. Therefore, GDPR does not apply. And that's the simple approach. But obviously, there's a lot more to read around how the data is generated and how law applies throughout the process. But in the end, the data, the synthetic data is a shareable asset. So let's talk about how it's created. And the process is called data downscaling. And we'll go through this fairly quickly, but the intent is to explain that we are synthesizing or generating data from observations of other data sets. And so in order to create a synthetic population of Canada, we start off with a data spreadsheet of 38 million rows so that it matches the size of the country in terms of population. And then for each column is going to be an attribute that we want to keep track of and apply to each of those synthetic individuals. And we're going to apply it in a synthesis process. So starting off with each synthetic ID, they have a number. The first thing is to apply postal codes. There's 825,000 postal codes or thereabouts in Canada, and we assign the right number of synthetic individuals to each postal code based on the Census of Canada. From there, we're going to start to add in other attributes based as well on the census. So we can look into the distributions of gender and apply that to each of the synthetic individuals. And then we can do the same with household income. And then we move sequentially from left to right across thousands and thousands of variables that need to be applied to each of the synthetic individuals. The process is called conditional probability. It's looking at many different attributes at the same time, and it knows that it has to apply a certain number of those attributes to a certain number of synthetic individuals. So the question is, which one does it go to? It's important that correlation is preserved, and that creates very structured data that allows us to use it in ways that are very useful for media and marketing. We can also add in other data sets. So we can bring in brand use, for instance, and apply those to the synthetic individuals. So now that that's done, the question is, what are the functional benefits? Well, as I've said before, sharing the data is probably one of the most important ones because it doesn't have that privacy consent management overhead. You can literally decide, okay, let's query the database, find all the synthetic individuals that have pets, and we can share that data with other um, stakeholders within the group to say, these are the people that we're trying to target. We can uncover correlations between these various variables. So we can look at the people who have pets, what restaurants do they visit, or what cars do they drive, or how much media time do they spend in certain areas. And it looks like this in our interface. So we've identified here about 2.5 million people who are interested in organic foods, and we're looking at their restaurant visits. And that's just a straight indices. Very simple sort of stuff, but in the background is the synthetic data that is uncovering these insights. Of course, that also means that we can use synthetic individuals to create reach frequency curves. When we look at their media habits, we can say, okay, if we're going to spend this amount of money in these different media channels, we can create a cross-media campaign. We can look at their reach frequency curves, and we can apply the amount of money that's being spent into each channel, and then look at it from a cross-media perspective of how much reach, how much frequency is going to be obtained within the campaign. We can then describe that campaign, and we can share it with the media vendors to say, these are the synthetic individuals that we want to target, but here's also the amount of money that we have allocated within each of the within the campaign. And so we're interested in getting more information from the media vendors on how they would address each of those different media channels against the synthetic population, which of course they can reference as well. We can add in additional business data, like in this case, mobility patterns. And so those mobility patterns can help us understand for that target group, where are they moving around the city by looking at a map and just saying, okay, well, we know where they live based on postal codes. We've identified the number of synthetic individuals that sit within each postal code. The red ones are the postal codes that have a high index. The blue ones are a low index. We have counts based on the number of those synthetic individuals. So it becomes really important to think about, well, obviously out of home you can use, or direct mail, but also you can look at markets for like terrestrial radio, newspaper, local paper, but you can also buy media based on FSA through social, and search can also be bought through geography as one of the variables. The mobility data starts to look at the postal code movement from one to the other in terms of volume, different times of the day, weekend versus weekday, and becomes very helpful to understand the exposure for out of home. And also, of course, store visits and specific points of interest. We also have to recognize that every first-party data set is a subset of the national population. So because we have a synthetic population of everybody's first-party data set is identified within that data set. So on the right-hand side, you have the big circle, which is the national population. A first-party data set is the smaller circle that sits within it, and everybody's first-party data set is somewhere inside that national synthetic population. Consent only has to be managed within the first-party data set. Once you can compare it against the synthetic population, you can uncover data you don't have. You can look at indices, where you're strong or where you're weak, and fill in some of the gaps. On the left-hand side, of course, you have the other approach, which is looking at a data clean room, where you take two very large data sets and combine them to see what kind of consent that you have between the two in the intersection, to see, can we reach and share data within that intersection. Now, of course, within a first-party data set, you don't have everybody. So you're already starting with a smaller group of people, less than the national population, and then you're comparing it with another smaller group as well. We can match data sets. Obviously, if somebody wants to compare the data, they can give us some variables, and then we can match that with the synthetic data population and send it back so that they can see more about their own data. And here's where it gets really interesting, I think, because you can have both the buy side and the sell side referencing the same synthetic population, that opens up the door for cross-media communication about the campaign. So on the left-hand side, you can have the buyers uh, set up the campaign, set up the target group, allocate monies, and then communicate with the buy side by sending over synthetic IDs and a cross-media campaign description and say, this is what we're looking for. And the media vendors on the right hand side can still reference the same synthetic population, same synthetic IDs, and go, oh, I know exactly what you're trying to do here, and then also fulfill on the media delivery side. Once that is done, that media delivery can be also applied to the synthetic IDs and sent back to the left hand side for deduplication. So you get actual cross media reach and frequency. Now, when you start doing this, you are addressing two big issues in the programmatic space. One is in the bid request, there's a ton of data that Johnny Ryan says is a massive privacy breach. Well, by removing all that data and instead having a synthetic ID, it really cements a whole bunch of privacy enhancing technology. On the right-hand side, you've got Dr. Fu saying that there's a lot of invalid traffic that's happening in these things, and a lot of it is being fueled by sort of multiple pixel firings throughout all the chain of command. And again, synthetic data starts to reduce the amount of data that is being sort of just plopped out into the middle of the programmatic ecosystem. You can also look at so from a marketer's perspective is say, let's do geoanalysis using synthetic data. So you look at a sales territory or a store, and you can see all the postal codes that are in the footprint. You can see the synthetic IDs within that footprint, which aligns with sales, which is creative testing, MMM by geo. All of this stuff aligns by geography. We did it. Here's an example. Winston did some work with Coke, 26,000 vending machines, Coke vending machines across the country, used synthetic data, mobility data to optimize the locations of these vending machines. And each one is its own little retail outlet, really. And that is to optimize the sales. So again, the modeling showed that they could have this uplift in sales by changing the locations of certain machines. We can also understand what is the impact of broadcast on search, which is an interim, a middle funnel report to say, well, if we can see paid search by geography, we can understand the effect where people are searching for certain brands. Of course, we can also see what retail outlets they're heading for. And it helps them to understand here is the push that's coming from broadcast that is being fulfilled on the lower funnel through the performance teams. So it really calls the question, why don't we think more about changing the frame of reference away from identity and pixels and attribution and more towards using synthetic data, using geography and marketing mix modeling to really uncover what's happening in our media buys. Which comes down to thinking about local media. And here we have Cape Breton, we have all of the postal codes and the synthetic data that is showing the target group, indices of the target group in a local area, which could be supporting DM, it could be supporting local print, local radio, and those are important sort of abilities if we want to actually further strengthen the Canadian media market. In order to do that, it has to be actionable. So not only do we have to have the synthetic data, but we also have to have it built into the planning tools. So in conclusion, what we see is that synthetic data really is a major innovation when it comes to marketing. It allows people to share that individual level data. Even though it's synthetic individuals, the model has a high degree of utility and a high degree of accuracy. It's not only operational at the local level, national level, but also we're going to start to see a lot more international synthetic populations as we start to see cross-media measurement rolled out in other countries. And it's important to recognize the privacy compliance aspect of the benefit of the use of synthetic data as consent becomes much more of an issue. So thanks very much for paying attention. If you have any questions, hit me up at chris@arimadata.com or here on LinkedIn. and happy to chat further.